So welcome to module 5 contents of material science and metallurgy. So we'll be discussing about what is composites. Composites have two phases, one is the primary and secondary. Primary forms the matrix within which the secondary phase is embedded. So there are three materials when we consider when we are going to take a composite material. It may be polymer, metals or ceramics. Secondary materials are referred, it may be embedded phase or reinforced engagement. So here secondary materials will be like fibers, particles, etc. It can be any one of the element like carbon, boron, silicon, silicon carbide, like these different materials we can reinforce. Further, if you take, there are five basic types of composite: fiber, particle, flake, laminar, or layered or filled composite. So here you can see different shapes: particles, how it is, lamina how it will be. So flakes are uneven surface, fibers are in the horizontal direction, so it will be uniform throughout the length. So filler material, it will be decided based on what material we add. So fiber composite, particle composite, laminar composite, flake composite, filled composite, like this different materials are added to the base material. According to that composite it has been defined. So if you take a classification of composite, there is MMC, that is Metal Matrix Composite, there is Ceramic Matrix Composites, Polymer Matrix Composites. So what are these three composites? Is mixture of ceramics and metals. It may be cemented carbides and other ceramides. Aluminum or magnesium reinforced by strong high stiffness fibers. At least common composite matrix will be there. Aluminum oxide and silicon carbide are materials that can be embedded with fibers for improved properties, especially in high temperature applications. Thermosetting resins are most widely used polymer in PMC. Epoxy and polyester are commonly mixed with fiber reinforcement. So if you go with classification of composite material, matrix materials serve several functions in the composites. Provides the bulk form of the part or product, holds embedded phase in place, shares the load with secondary phase. So reinforcing phase, it may be in terms of fiber, particles or flakes. So here how you orient the fibers is important, and it is one dimensional. So you are going to add the fibers where in what direction you will be having the maximum strength and stiffness. So if it is planar, means it is in the form of two-dimensional woven fabric. If it is random, means it will be three-dimensional. So this may be used for reducing the porosity or to fill the gaps inside the composite. So reinforcement, there are different reinforcing material like glass, carbon, boron, Kevlar. So if you take glass, it is most widely used in the polymers. So GFRP, that is the glass fiber reinforced plastic. E-glass, S-glass are different type of materials where you can take the selection of glass material. So how the materials are added in the required phase, so that there will be maximum utilization of the material. So it will be in the form of rowings, it may be continuous arc-funds, it may be in the strand mat or chopped strand mat, surface feeds. So like this different materials are displayed here. So as I told, reinforcement phase are made up of different materials. So here he has named the different type of materials what we can add as a reinforcing phase. So in the polymer composite, what we can do is fiber reinforced plastics are most commonly identified.